How do farmers use modern machinery to harvest millions of tons of crops? Have you ever wondered what happens behind every brilliant harvest season, when millions of tons of produce are gathered in just a few short days? Behind that spectacular sight lies a world of technology, where massive machines, intelligent robotic arms, and sophisticated automation systems are transforming the face of global agriculture every single day. From the heavy apple orchards in Washington, the endless carrot fields across Europe, to the enormous center-pivot irrigation systems in the deserts of America, all reveal the extraordinary power of modern farming. Today, let's explore agriculture and discover how farmers harness advanced machines to create record-breaking harvests. First, let's visit Washington State, the land famous for its vast apple orchards in the United States. Here, apple harvesting is done by giant shaking machines weighing up to 10 tons, specially designed to replace manual labor. Among them, there are two main types of machines most commonly used. The first type operates with a hydraulic arm that grips the trunk tightly, shaking it vigorously for a few seconds until hundreds of ripe apples fall quickly to the ground. Immediately after, a specialized apple gathering machine moves in, sweeping the fruits from both sides of the row and collecting them neatly into a center line. Next, the harvester moves along the tree rows with a conveyor belt positioned close to the ground. On this belt, soft rubber fingers rotate like mechanical hands, gently picking up each apple, lifting it onto the main conveyor inside the machine. There, powerful fans blow away dry leaves and dust before the apples drop into large bins or wooden crates, ready to be transported to the warehouse. This method significantly increases productivity, allowing up to 10 to 15 tons of apples to be harvested per day. However, the bruising rate is quite high, so these apples are mostly used for juice and processed products to meet the demand for premium fresh apples. An improved shaking machine was developed, equipped with an integrated catching frame. When the tree is shaken, the apples fall directly onto this frame and are transferred straight into containers without bruising, making them ideal for export. An apple tree usually takes 4 to 5 years to yield its first harvest. This difference in harvesting technology reflects the diverse needs of the market. In addition, another type of machine was developed to further reduce bruising, though it is less common than the previous two. This machine moves along the rows, using soft rotating brushes that sweep through the canopy, causing fruits to fall into collection trays. From there, they are conveyed onto the main belt and stored in rear bins. This mechanism allows the machine to move continuously between rows, harvesting efficiently while keeping the fruit intact. The most remarkable development in apple harvesting today is the emergence of intelligent robotic arms. The days when dozens of workers had to climb ladders to pick each apple by hand are long gone. Thanks to AI-powered cameras, these robots can identify ripe apples, extend their arms, grip precisely, and harvest thousands of fruits per day. This technology not only accelerates the harvesting of millions of tons of apples, but also boosts the overall economic value of the entire season. Now, let's move on to carrots, a crop typically harvested between September and November when they reach peak crispness and glossy skin. In major production regions such as the Netherlands and Germany, farmers no longer rely on manual labor. They use specialized carrot harvesters, advanced machines that not only pull carrots from the ground but also integrate systems to remove soil, cut off the tops, and perform initial sorting right in the field. A single carrot harvester can replace the work of hundreds of laborers working day and night, keeping the carrots clean and almost unbroken. From above, thousands of bright orange roots flow across conveyor belts, creating a stunning scene of large-scale harvesting. Thanks to this technology, Europe produces millions of tons of carrots every year, serving both fresh consumption and processing industries. Next, let's explore onion fields, where the harvesting process looks entirely different from most crops. Instead of being collected directly into bins, onions are lifted and neatly lined up in long rows by a gathering machine. They are then left to dry naturally under the sun for 10 to 14 days, allowing the outer skin to harden, extending their storage life considerably. After sun and wind drying, the onions are collected using gentle rotary harvesters that lift each bulb onto a conveyor lined with soft brushes and air blowers, removing soil and loose skins. Market-grade onions fall into large bins on parallel trailers, while the lower-quality ones are separated for processing. Before the next planting season begins, deep plowing machines dig through soil layers unreachable by human hands. With massive blades cutting up to 60 to 70 centimeters deep, they not only turn the soil but also break up compacted layers beneath. Each pass leaves long furrows of loose soil, improving rainwater absorption and reducing flooding risks. In Europe and the US, deep plows are often used before planting grains or oil crops, preparing hundreds of hectares for the next season. Meanwhile, shallow plows are far more common. Unlike the giant machines that break hard soil, shallow plows operate at a depth of 15 to 25 centimeters, focusing on aerating the layer where seeds will be sown as they move. The blades not only loosen the soil but also mix in crop residues, dry leaves, and organic matter, turning them into a nutrient-rich humus layer. This process also suppresses weeds and eliminates pests left from the previous crop, creating an ideal seedbed. Shallow plows have become essential on most farms, especially before planting rice, corn, or vegetables. Once plowing is complete, massive seeders take over. These machines stretch across the field, their long arms spanning tens of meters like a giant steel frame laid on the ground. Above them sits a large seed tank that feeds seed tubes running along each arm as the machine moves. Each tube drops seeds precisely into preset positions. Then, a soil pressing component gently covers the seeds, ensuring firm contact with the soil and creating the best germination conditions. Some modern seeders are equipped with positioning systems and smart sensors that help maintain perfectly straight planting rows, control seeding rates, and minimize seed loss. This technology not only helps farmers reduce costs, but also ensures high and uniform germination rates, resulting in stable yields throughout the entire season. Across modern farmlands, central irrigation pivots rotate around a main axis like a gigantic clock hand. As they move, sprinkler heads distribute water evenly across the field, creating vast circular patterns that can even be seen from the air. A single pivot irrigation system can cover from 50 to 130 hectares using only one central well. Newer models are equipped with soil moisture sensors that allow remote control via smartphones and can automatically adjust the water flow precisely down to each square meter. Thanks to this advanced technology, arid regions in Nebraska, Texas, and Arizona have been transformed into fertile farmlands growing corn, peanuts, and soybeans, helping the United States maintain its leading position in global agriculture. Next comes the automatic tree pruning machine, a specialized device designed to trim various types of industrial trees, from apple and orange orchards to pine forests. Its long hydraulic arms, fitted with high-speed rotating blades, can extend over 6 meters to handle even thick, large branches as it moves along the rows. The machine trims neatly, keeping the canopy open, balanced, and healthy. The flexible hydraulic system allows adjusting the cutting angle to suit each crop type. Thanks to this, a single automatic pruning machine can complete the trimming of several hectares of orchards in just one day, saving significant time and labor costs. In the state of Oregon, pine tree pruning is carried out very efficiently, but with a notable difference compared to traditional manual methods. Instead of trimming each branch by hand, workers use a special circular cutting device that moves along the tree rows. This component surrounds the canopy and prunes evenly from all sides, helping the trees maintain a balanced, attractive shape. As a result, each tree forms a perfect cone, ready for the Christmas season. Continuing the journey, let's explore the peanut harvesting process, which is carried out in 2 main stages. In the first stage, a specialized digging machine uses sharp plow blades running close to the soil surface to cut the roots while gently lifting and flipping the entire plant. At this point, the peanut pods still attached to the roots are brought above the loose soil, exposed to air, ready for drying and the next collection step. After a few days of sun drying, the process enters the final harvesting stage. Now the harvester begins operating. Conveyor belts automatically collect all plants, separating the pods from the vines, while strong air currents blow away remaining soil. The clean, firm peanut pods fall into storage bins, while the vines are returned to the ground as natural fertilizer. With modern machinery, these harvesters can process 5 to 6 tons of peanuts per hour, a productivity level manual labor could never match. After finishing the peanut harvest, we move on to the vast cornfields, where sweet corn plants grow rapidly and must be harvested at the exact moment when the kernels reach full sweetness. The massive harvesters operate like mobile production lines, their hydraulic arms gripping the stalks tightly, sharp blades cutting cleanly, and the corn cobs being lifted up. Rollers then strip off excess leaves before placing the cobs onto conveyor belts. Within seconds, the harvesting process is completed, and within minutes, the refrigerated trailers behind the machines are filled with fresh corn. In the U.S., about 137,000 hectares of sweet corn are planted each year, but over 90% of the harvest is not sold directly on the market. Instead, within 8 to 12 hours after harvesting, the corn is transported directly from the fields to processing lines for canning or freezing, preserving the natural sweetness and freshness of every cob. Next, let's take a look at pistachio harvesting. The season usually takes place from August to September, when the nuts are fully ripe. This process uses hydraulic shaking machines that clamp onto the tree trunk with soft rubber pads, shaking it without damaging the bark or branches. When in operation, the machine's arm delivers powerful vibrations lasting just a few seconds, causing thousands of ripe pistachios to fall simultaneously beneath the tree. Two giant catching frames open like umbrellas to catch the falling nuts before folding up and transferring them onto conveyors. From there, the pistachios are lifted into storage bins while air blowers remove leaves and dust, protecting the soft outer shells from mold and preserving the best quality. Although Iran has long been regarded as the cradle of pistachios and once held the world's top production rank, in the U.S. market, nearly all pistachios consumed come from California. Thanks to its hot, dry climate, fertile soil, and advanced farming techniques, California has transformed this Middle Eastern crop into a billion-dollar industry, bringing immense economic value to American agriculture. Did you know that a single sunflower head can contain 1,000 to 1,500 seeds, arranged in a naturally perfect spiral pattern? However, that bright beauty fades as harvest season arrives. The fields lose their golden color, turning gray and brown as the drooping heads await collection. When the harvest begins, sunflower harvesters roll into the fields. The machine's cutting blades guide the tall stalks into the threshing unit, where the dry flower heads are pulled into the drum and thousands of seeds are separated within seconds. Leaves and husks are blown away by the wind, while the glossy black seeds flow down the conveyors, filling the bins behind in just a short moment. The once silent summer field turns into a living river of seeds, the beginning of their journey to become cooking oil and many other sunflower-based products. Continuing the journey, we arrive in Washington, the kingdom of frozen red raspberries, where more than 36,000 tons are harvested every year, accounting for over 90% of the U.S. supply, making this state one of the largest production centers in the world. When the first raspberries of the season begin to ripen, harvesting usually takes place in midsummer when the berries are bright red, juicy, and perfectly round. Depending on the scale and purpose of cultivation, farmers may choose to handpick to preserve the quality of each berry or use machinery to maximize speed and productivity. And large-scale raspberry farms like those in Washington and California, mechanical harvesting has gradually become the standard. Machines worth more than $200,000 operate like a symphony of technology, gently shaking the canes with fiberglass rods so that only the perfectly ripe berries fall. The fruits are then transferred into an integrated conveyor system where strong air jets blow away dry leaves and debris along the line. Workers sort on the spot, keeping only the evenly colored, flawless berries. Thanks to this process, a farm of nearly 40 hectares can complete the entire harvest within a single week, fast, efficient, and maintaining consistent quality, ready for the next stage of production on smaller farms or those serving premium markets. Raspberries are still picked entirely by hand, the only method that guarantees each berry retains its perfect shape without bruising. With thin skins and hollow cores, raspberries are extremely fragile to pressure or impact. Handpicking allows workers to choose berries at the exact ripeness, avoiding underripe or overripe ones. This is especially crucial for cold storage and post-harvest transportation. Immediately after picking, trays of raspberries are loaded onto refrigerated trucks and delivered directly to nearby processing facilities. Transport runs continuously, without intermediate storage, to preserve the delicate freshness of these. Tenderfruits.at, the processing plant, specialized conveyor systems carefully move each tray of raspberries to the receiving area, where automated unloading systems take over. Each tray is gently tilted, allowing the berries to slide onto conveyors without being crushed or dropped. Every motion is precisely calculated to maintain the delicate perfection of this precious fruit. From the receiving area, raspberries enter the cleaning process on the conveyor. They are washed using extremely low pressure water jets, no stronger than a gentle shower stream. This delicate handling is essential, as even a slightly stronger force could rupture their fragile skins. The washing water is continuously filtered and reused, ensuring hygiene while also protecting the environment. After washing, raspberries move to the sorting section, where workers manually inspect them on continuously moving conveyors. Bruised, misshapen, or unevenly colored berries are removed, leaving only those that meet strict standards of shape and color. This step plays a crucial role in ensuring uniform quality for the entire batch. Next, the raspberries are sent to the packaging area, where each tray undergoes a final inspection before being sealed. Inside protective packaging, with labels indicating origin and harvest date, the trays are packed into large boxes, ready for shipment to supermarkets, wholesale markets, or export abroad. The entire process is strictly controlled to ensure that every raspberry reaching consumers is as fresh and flawless as possible. How do you feel about the miraculous journey of modern harvests, where machines and technology help humans collect crops faster and more efficiently than ever before? If you find it fascinating, don't forget to subscribe to Hands of America Discovery to continue exploring more incredible secrets of smart agriculture around the world. Thank you for watching, and see you in the next video.